Hey there. You know that feeling when you're staring at a math problem and it just seems impossible? And then you find out there's this one simple, elegant key that unlocks the whole thing. Well, today we're going to find that key. We're talking about a really common puzzle in logarithms, one that even your trusty calculator gets stuck on.
So the problem we're diving into today actually starts with that tool we all rely on, the calculator. I mean, these things are amazing, right? But it turns out they have this surprising blind spot. There's a whole category of problems that they just can't solve directly.
Okay, so here it is. How would you solve this? Log base 7 of 2401. To put it another way, 7 to the power of what gives us 2401? Now, your first instinct is probably to grab your calculator, right? But that's exactly where you're going to hit a wall.
And here's the thing. Take a look at your calculator. You've probably only got two log buttons. Log, which is base 10, and ln, the natural log, which is base e. There's no button for base 7, or base 5, or base 12, or, well, anything else. So are we just stuck? No way. Not even close.
All right, so to find the solution, we've got to take a quick step back. Let's do a quick refresher on what logarithms actually are. And trust me, this isn't just some abstract math concept. Logs are an incredibly powerful tool for taming numbers that grow at an absolutely insane rate.
So everything really starts with exponents. You know that little number up top? It just tells you how many times to multiply a base by itself. So 10 to the power of 3 is just 10 times 10 times 10, which is 1,000. Pretty simple, right?
Okay, so a logarithm, it does the exact opposite. It's the inverse. It starts with the big number, like 1,000, and it asks a question. Hey, working backwards, how many times did we have to multiply 10 by itself to get here? And the answer, of course, is 3. They're really just two sides of the exact same coin. Think of it like this. Exponents are all about growth, about building numbers up. Logarithms are about scale. They break those huge numbers back down to their core power. It's this perfect symmetric relationship. And believe me, this isn't just stuff for math class. Logarithmic scales are literally all around us. It's how we measure the massive power of earthquakes on the Richter scale, or the intensity of sound in decibels, even the acidity of something on the pH scale. Logs help us make sense of a world where things can vary by these just huge, huge amounts. Okay, so now that we're all on the same page with the basics, let's circle back to our calculator problem. The solution, the key that unlocks this whole thing, is an incredibly powerful tool. It's called the change of base formula. This formula right here, it's basically our universal translator for math. It lets us take a logarithm in any base, like our tricky base 7 problem, and it translates it into a simple fraction, using logarithms that our calculator already knows how to handle. You know, like the natural log or the common base 10 log. And this is the really cool part. With this one formula, those two little buttons on your calculator, log and ln, that's all you're ever gonna need. Seriously, we can now solve for any base. The calculator's blind spot, it's gone, wiped out. Now, I know this might seem like some kind of math magic, but it's really not. It's built on the basic ideas of logarithms that we just talked about, just put together in a few logical steps. So let's actually walk through how we get this powerful tool. So here's the game plan, our 5-step roadmap to building this formula from scratch. We're going to start with a basic definition of a log, apply one of its standard rules, and then use a little bit of simple algebra to get what we want. Let's see exactly how it works. Okay, step 1. We're just going to state the problem in a different way. So we take our general logarithm, log base a of b equals x, and we just rewrite it in its exponential form, a raised to the power of x equals b. Remember, these two things mean the exact same thing. All right, next up, we do the same thing to both sides of that equation. We take the natural log. Now this is where the real magic happens. There's a fundamental property of logarithms called the power rule, and it lets us take that little exponent x and bring it down from the top, right out in front, as a multiplier. This one move is the key that unlocks the whole formula. And from here, it's just a little bit of simple algebra. To get x all by itself, we just divide both sides by the natural log of a. And then for the final step, we just swap that x back out for what it was at the beginning, our original logarithm. And just like that, boom, we've built the change of base formula. Okay, so we've defined the problem, we've gone over the concepts, and we've actually built the tool ourselves. Now it's time for the really satisfying part. Let's go all the way back to the beginning and solve that puzzle. Remember this guy? The logarithm, base 7 of 2401? Just a few minutes ago, our calculator was useless for this. But now we're ready.
All we have to do is apply our new formula. We just translate that base 7 problem into a fraction our calculator can finally understand, the natural log of 2401 divided by the natural log of 7. And now it's literally as simple as punching a couple of buttons.
And the answer is 4. That's it. Clean, simple, elegant. And if you check it, 7 to the 4th power is, in fact, 2401. Puzzle solved. So, the big takeaway here is simple, but it's also really powerful. You are no longer limited by the buttons on your calculator. You now have the key to compute any logarithm with any base you can possibly think of. So, you've got the universal key for logarithms. The only question left is, what doors are you going to unlock with it? What other huge, intimidating numbers are you ready to tackle now?